Hi everyone, welcome to Nick IT Academy. In this series, we are learning Teradata completely. In our today's session, we are going to learn about unique primary index, what is UPI, how it can be created, what is secondary index, unique secondary index, non-unique secondary index, what is partitioned primary index, and what is skewness, what is 1 AMP operation, 2 AMP operations, and Teradata data protection methods. And we are going to learn about Teradata data protection methods. We do have many concepts in data protection methods, like we have node level, AMP level, and disk level protections. We have RAID concept, fallback concepts, and click and lock concepts. So that we are going to learn about. So keep watching the session without skipping it. If you haven't subscribed our channel, please subscribe the channel and click on the bell icon so that you'll be getting all the notifications. Thank you. Let us start our session. Like primary index is nothing but whenever you are creating a table, if you mention, so it will accept the primary index. If you don't mention, it will take first column as the primary index. But so after the Teradata 13, so we have that like no PA concept. So nowadays in real time, if you don't mention in our real time, so if you are not mentioning a primary index, so this table will be taken as no primary index table, no PA. So it's based on the company, how they are defining it, the admin level. If you don't mention, the first column will be taken as primary index. Okay, that is what a normal scenario, default scenario. So even you can go for 2 or 3 columns for the indexing, and up to 64 columns you can go for the indexing. So how the indexing will be working? So if you are creating index, primary index or unique primary index, it will be a 1 AMP operation. I told in the morning, right? So 1 AMP operation, how it will be working. So you assume that this is for the record. Okay, record from the table, that client machine we are getting from application or from the client we are passing it record. The ID column is like 2, 32, 67, 12 something. Some ID columns we are getting from the client, from outer world to Teradata. Then how it will be processed, right? So it's based on the indexing, like either it's a UPI or PI. It will create, the Teradata will create hash algorithm. Okay, the parsing engine will create the hash algorithm first. Okay, based on the primary index. So hash value for each and every record, the Teradata will create one hash value. So say for example, for this particular record, it is creating a hash value called 646. Okay, it will be maintained in one table called hash map. Okay, hash map table. So it will have the hash value, and each and every record will have the hash value, and based on the hash value, it will have which AMP it is available. Okay, that particular record, which AMP. So based on the value, so if it is a unique primary index or primary index, it will have different AMP, right? So it will assign different AMP. This is what we will have. So if all the records are unique, then eventually it will be distributed, all the AMP. Okay. If you are getting duplicate value on the column, then one single AMP will have more value. Why? Because the hash value will be same for same record. Okay. So if I'm getting again 32, the hash value will be generated like 646 only. Same hash value will be generated. So if it is generating same hash value, then it will be assigned to the same AMP. It will go to the same AMP now. Okay, so that is why if you are getting more duplicate value on the column, so one single AMP will be getting skewed. So this is what we will say, like AMP has been skewed. Okay, so it should not be. That is why we are going for combination of columns. If you are going for combinations of column like primary index or unique primary index, so that column will not have more duplicate value, right? So that is why we can choose a primary index to avoid the skewness. This is what the algorithm will be maintained. So for example,
But
we are
algorithm and all will be taking care by Teradata only.
Teradata. We are not going to take care. So just we are creating. So our aim is to create the indexing. That's all. Okay. So finally, we have to tell them like if you are all the column mentioning, right? After that, you have to mention, close this bracket. Okay. Here we are opening the bracket, right? So close this bracket here and then tell like which column is primary index. Primary index of country code, center, local ID. So country code is the first column, center local ID is the some other columns. Okay, some other columns will be there in the so second column. We have a column. So we have to mention in this way. Then Teradata will create one hash value. It's like a number. It will create one hash value. Then based on the hash value, it will assign a AMP. This is like so either primary index or unique primary index. It will be a one AMP operation. Why? Because it will go to one single AMP only. So retrieving as well as storing the data, it will go for one AMP operations. So here, if you are creating a table, while creating itself, you have to tell like either it's a primary index or unique primary index. If you are mentioning like unique primary index, that particular column will not accept duplicate value. It's like a primary key. Okay. So normally in Teradata, we will not create a table like primary key. So we will create like unique primary index. Got it? If you are mentioning a column as unique primary index, that particular column will not accept any duplicate value. So normally unique primary index definitely will not have any duplicate record. So all the AMP will have eventually distributed.
Yes.
So hashing algorithm will be created for each and every record. So based on the retrieval as well as storing, it will go to the particular AMP, it will store the data. So this is what it will have a unique primary index. Okay. So this is what I have explained, unique primary index, how the data will be. If it is, if you are not selecting the primary index correctly, then one AMP will have more data. Okay, one particular AMP will have more data. Then this, we will call it as this has been skewed. Okay, to avoid that, we have to choose correct index. Okay, skewness. It is not
The
distributed.
problem will be like while retrieving the data, it will
Yeah, it
take
retrieving
time.
as well as storing the data. It will go to one particular AMP. Okay,
Okay.
sometimes the Teradata admin team, they will send a mail like this table has been highly skewed. Look into it. Okay, then we have to check for so select star from the table. Okay, we have to mention like so select star from the table, right? It will show you that create table structure. Then you have to check which column we have chosen that primary index. Then go to the table. You check for that particular column. We do have duplicate record or not. So how many duplicate record we have? You check the combination of column or the single column. So you decide that okay, it should not be a primary index. Then you create a backup of the table and create another table with some other column as primary index. Okay, you change that primary index. Again, store the data from that table to this table. So that is the way you can avoid that skewness. It's very rare scenario after creating the table, but by creating the table itself, we have to check the tables and all, the initial stage itself, the record and all. Based on that, we have to choose the primary index. Okay. Then secondary index. So you have created one table with the primary index. Okay, you have one table with the primary index, but you are querying the table with a different column. You are querying that column with a different column. Okay, so you take this state, this sheet. For example, you have the customer table. Assume that I have the customer table. You are having the customer ID and customer name. Like another column is called mobile number. Okay, mobile number. Then you have something like city column, then date of birth. Okay, this is what column I have. So you are fetching the data based on the customer ID. So that is what you have given that primary index. Sometimes you will be fetching the data based on the mobile number also. Select star from the table where mobile number equal to this way. You are frequently accessing another column, not this column. Okay.
Okay.
So either this column or this column you will be accessing it. So this column you have access, you have created as primary index. You cannot create one more column as primary index, right? You cannot
Yes.
create one more column as primary index. So if you want to create, so this will be a unique primary index. You assume that it should be a USI, unique primary index. Okay. Then you have to create one more column as indexing column. Separately you have to create. Why? Because you are separately querying that column multiple times, single column. So for this column, you cannot create again indexing. Like primary index, you cannot create. If the table contains already index, this column will be a secondary index. If you are creating this column, it will become a secondary index.
Okay.
Secondary index is nothing but you are fetching the column It is an alternate path, okay, for the data retrieval as well as data storage. Got it? Instead of
Yes.
going for this column, you are going for different column. Then how it will be maintained in this database, right? This is two-arm operation. We will call it as two-arm operations. So normally the data will be stored based on the unique primary index only, or primary index only. In the AMP, it will distribute the data based on the primary index only. For example, here I have ID, some ID columns. So based on this ID column, it will distribute the data in the AMP. So different AMP, it will distribute. But this is like something like mobile number. Some mobile number you have. So based on the mobile number, you are fetching the data. So this is an alternate access path. So you are fetching the data in different way. So how the Teradata will maintain? So so if you are going for secondary index, okay, either it's a unique secondary index or non-unique secondary index. If it is a unique secondary index, this is also a unique column. Okay, it will not accept any duplicate. So if you are going for some non-unique secondary index, then it may have duplicate value. First, we will go with unique secondary index. How the unique secondary index will be maintained. So if you are going for unique secondary index, how the data will be. So first of all, this is the algorithm. Okay, you take it like select star from customer where mobile number equal to some number. Instead of customer, you take it like mobile number. Something secondary index column we are going for. This is not actual column. This is secondary index column we are going. So hashing algorithm will create on hash algorithm. This is since it is the secondary index column, how it will be hash map. The secondary index, a subtable will be created. A subtable will be created in all the AMP. All the AMP, a subtable will be created. And also, remember this in Teradata, whenever you are creating the table, right? Whenever you are creating the table, like create table, table name, the structure will be maintained in all the AMP. You remember this. Whenever you are creating a table, it will not have one structure. If I have 4 AMP, right? 4 AMP, 4 AMPs will have the same structure of the table. Okay, this also will have the structure of the table. This also will have the structure of the table. This also will have structure of the table. This also will have the structure of the table. So it will have the ID called 2. This will have ID called 3. This will have ID called some 4 or 5 something. Okay. So if I have 4 record, the same structure will be maintained in all the tables, all the AMP, but you'll have one record. Whenever you are creating an table, right, the structure will be created on all the table, all the AMP. Okay. The data will be saved based on that record which we are passing it. The same way, if you are creating a secondary index, okay, secondary index, a subtable will be created on all the AMP. Okay, Teradata will create a subtable in all the AMP.
Okay.
So all the AMP it will create. So for example, if you are having like a mobile number equal to 998, something you are having, then hash value will be created for that particular row. Then this is like hash map. This hash map will have where is the subtable resides. Okay. It will have the hash bucket number 602 and AMP number and base row value. So base row value is nothing but it's based on the primary index value. So the record will be stored in the database based on the primary index, right?
Yes.
But this is the alternate path we are querying the table. So the record will be saved in the AMP based on the index, the primary index only. But this is an alternate path. So for example, this will be AMP number 1, 2, 3 or something. So based on this, the another path, right? The another path, it will have where the base row has been stored. It will, the hash map will have, remember this, okay, carefully listen. The hash map will have, where is that hash bucket? Hash bucket number is 602. Okay. Then AMP number 2 is the subtable, where the subtable will be maintained. It will be AMP number 2. Where is that base row? It's 778. It will go to this particular the AMP number 2. It will check for the subtable. So each and every AMP will have the subtable, right? So this AMP will have the subtable called hash value 602 and AMP number 4. It will tell you like the base record is present in the AMP number 4.
like it that hash bucket number will give not actually the where the record is located in which AMP. It will
Yeah,
give the
the AMP number.
subtable
Yeah,
AMP
subtable
number.
information. Subtable information. This
Yes,
subtable will give you that where that base row located.
where the
Got it?
actual record is located.
Yeah. So it
Yes.
will give you AMP number 4 and then base row ID is 778. So the
Okay.
Teradata will go to this particular AMP number 4. It will check for the row ID 778. It will pick the data and then it will give you that result. Okay. Okay. So
Okay.
for this 998, this is what the record it will give you. So this is
Yes.
like 2 AMP operation, not only 1 AMP. It's
Yes.
AMP number
Yes.
2 also
Yeah,
involved.
with only
And AMP
primary index, that is a 1 amp, and with the secondary index, it will be a 2 amp.
2 AMP operation. Okay. For
Yes.
example, if you are going for unique primary, unique secondary index, this is the operation. If you are
Mm-hmm.
having any duplicate record, okay,
Oh,
there is
okay.
no other row will be created on the AMP number 2. For example, AMP number row, this will not create another row. It will say like, so based on the, for example, you are having the same record 988 here. It is like a
Mm-hmm.
duplicate, right?
Mm-hmm.
Duplicate, correct?
Yes. Yes.
So
Yeah.
for these
Duplicate.
two record, for those, this is like a non-unique secondary index, correct? Non-unique
Yes.
secondary index. For the two
Mm-hmm.
record, it will have the same hash value. The row ID will be different, 778 and different value, the row number.
Okay.
So, but the
Mm-hmm.
same record, the subtable will have that 778 comma the another row number. So, for
Mm-hmm.
example, 640, it will have that ID, then it will go to that particular ID, and then it will pick the record. It will not
Okay.
create two record for the non-unique secondary index. Only one record will be created on the subtable. Got it? This
Okay.
is also a second. This is also 2 AMP operations.
Mm-hmm.
So this is what it will be explained here. If you go through this, then you can able to get it clearly.
Oh, oh,
Okay.
oh.
This is like something like we will get some duplicate record. So here, name column we are fetching it, right? Select star from
Mm-hmm.
customer where name equal to Adams. Might be Adams will have two names. See here, Adams here also, right?
Mm-hmm.
Adams.
Mm-hmm.
So this is secondary index.
Okay.
Customer is the unique primary index. The name is the secondary index. Adams is two numbers, but the row ID is 222 and 115, right?
Okay.
The subtable will have that 222 and 115 on the same AMP.
Yes.
Okay, same AMP.
Okay.
Based on that, it will pick the record. Okay,
Okay.
5672 5671. It will go here and then it will check where is that row ID. It will go to this particular row ID, 222 and 115. It will pick that particular record from the AMP number, some different AMP, and then it will pick the record. So this is what it will go for the non-unique
Ah,
secondary index. Got it?
okay. Okay.
Primary index, unique
Ah,
primary index,
yes.
secondary index, that is non-unique secondary index, and unique secondary index. So this is what we will create. The join index concept I will tell you after some time. Then
Okay.
next one is like partition primary index. Okay,
Okay.
this is another index on the same app. We'll go for partition. Okay,
Mm-hmm.
we are distributing the data right on the same app.
Okay.
While distributing the data, we are partitioning it. So partition primary index is the distribution of row based on the different partitions for the faster retrieval. So where we will create the primary partition index, right? This one, PPI. For example, you have the transaction date. Okay, some date column, order date, some transaction date. On that column, we will create PPI.
Okay. This is also while creating the table only we have to decide like
Yeah, definitely. So while creating the table, we have to mention that PPI column.
primary. What will be the syntax then?
So here we will mention, okay. So primary index
Okay.
order number, primary index is order number only. Partition by range, we are creating say order date between this date to this date. Each interval is 7 days. Normally
Okay.
we'll go for 1 day. So each day will be 1 day. So this is for 1 year they went for, right? 1 year. So 1st January to 31st December, right? So each partition will have 7 days of data. Normally we'll go for 1 day. So 1 day once we are creating it, assume that. Okay. So order number, primary index is order number only, but order date is partition. For example, order date. So we are having like there we have created like 7 days, right? 7 days or 1 month. This is like 1 month. See now, we are fetching the data based on this. So we have the 4 amp here. Okay, 4 amp here. So it's based on the UPI, right? The order number. The order number it will be distributed, correct? So 1 is here, 2 is here, 3 is here, 4 is here, like 5, 6, 7, 8. This distributed based on the UPI. But we are creating one more column, order date. It's a partition. So if you don't create partition, if you are fetching the data, so within this, some order date you are going for. For example, you are going for select star from the table where order date equal to this date. Since it is not a primary index, Teradata will confuse that where the data is has been reside, right? So this is green color is January and yellow color is February. So it is not eventually distributed. But if you are creating partitioned primary index, then within the AMP itself, it will partition. So the above will be January, the below will be February. Normally, we will create like transaction date, order date. Each 1 day will be on one partition. So within the AMP, we will go for the partition. It will distribute the data based on the primary index column only. But within the AMP, we are going for, anyhow, this is also one table, right? As I told, every AMP will have separate table list.
Yes.
Again, this table will have some data. Within this table, we are going for partition. So this is what partitioned primary index, PPI column. Okay. So PPI column, this is what the syntax you have to follow. If you check some other table syntaxes in real time, go and check how to check it, right? So you will have some column like a transaction table or some table. Like you can check like this. Okay. If you are going for show table, okay, show table, table name, it will give you that something like order table, for example, order table. It will give you that normally here we have to mention like a DB name. So which DB is present? DB name dot table name, you will make it. In our database, we have some database DB1, DB2, something. We have something like production, okay, P underscore tables, production table. We have the table name. So you can show in this way, or you can go for show select star from the table name. If you are mentioning this also, this will give you the structure of the table, how it has been created. There you can check the create table structure, how it has been created. Okay, you can check how they have created. They have mentioned in this way, primary index and partition by something. This is a PPI column. So definitely the large table, right? Transaction table and all, they will create PPA. Transaction table, sales table, some invoice table, like fact table. You know the fact table, right? The fact table will have, they will create like a partition primary index. So indexing the secondary index, what is the disadvantage of secondary index? Again, it will create the subtable, right? So that is a disadvantage. And also if you are going for some fallback operations, when we are creating the fallback table, so it will maintain the data in the different AMP. Then it is a overhead to the subtable information. Okay. So PPI definitely needs additional space, like what 2 KB per row. So why? Because it is again this partitioning, right? This information is creating, like each and every AMP is creating. So each and every row it is like another 2 KB of data. Then it is again the space wise it is overhead. So that is what the indexing concept. Anyhow, we will create this concept. You will see again this concept while seeing that create table structure. So now we will see that something like the data protection. What is the data protection? All those. Then we will see like the RAID concept. All those, right? The data protection is nothing but how are we going to protect our data? Okay, in the fault tolerance, something goes wrong. Okay, something goes wrong in our Teradata environment. How are we going to retrieve the data? Okay, so
Okay.
it has 5 different level. Either can be a disk failure, okay,
Okay.
the storage failure, or it can be
Mhm.
a node failure. The entire node can be failure, or it can
Mhm.
be a AMP failure. So one AMP is failed, then how to retrieve that particular AMP data, right? So the data has been stored in one particular AMP, so you cannot retrieve it if the AMP is failure. Or transaction
Okay.
level. If you are doing some operations, some select operations or insert operation, in between something
Mhm.
happened, some data only will be inserted, right? So how to
Mhm.
retrieve the other data? Everything we are going to see like transaction level and the object level.
Mhm.
Object level is nothing but the table level. So we have different method. So first method is called RAID method. RAID,
Mhm.
okay. It's a disk level protection or disk level data protection. RAID is nothing but redundant array of independent disk.
Mhm.
Redundant array of independent disk. So we have different. So RAID is a concept actually. It is like a
Okay.
concept. Teradata have used RAID 1 and 5. 1 and
1 and
5.
5.
Yeah.
Okay.
So RAID 1, RAID 2, RAID 3, we have different RAID concept for the database environment. So Teradata,
Mhm.
they have taken RAID 1 and RAID 5, okay, for
Mhm.
the disk failure. So RAID 1 is nothing but disk mirroring. Okay, so we have the disk mirroring concept. We have the AMP and then disk, right? The virtual disk we have.
Yes.
In Teradata, it will have the disk mirroring. So we will mirror that. Okay. So something like EMC square logic we will use. It's a disk mirroring is RAID 1 concept. Okay. RAID 5. RAID 5 is nothing but some other concept. It's a data parity protection. So wherever you have something like array of data, okay, it's nothing but whenever you are going for you have the data warehouse environment, right? You have the data warehouse
Mhm.
environment. Some data only we will frequently query that data, right? You will not query like 5 years of data or 10 years of data frequently. You will query, but not frequently. So whenever you are having you are not querying the data, that will be maintained in separate, so separate disk. Okay, you are not going to query that data. But whatever you
Okay.
are querying frequently, that will be mirrored out. Okay, so you
Whatever.
are, for example, you have IRCTC.
Okay.
Last 4 months only you will be frequently querying, right? Last 1 year.
Uh-huh. Yes.
You will not query like last 10 years of data.
Yeah.
That 10 years of data will be maintained in one disk. Okay, we will not go for something like mirroring. But whatever we are frequently querying, that will be mirrored out. Okay, last five
Okay.
years only we will mirror out. So that concept will be RAID 5. But RAID 1 is
Uh-huh.
like all the data will be mirrored out. Mirroring. For example, RAID level. So mirroring and do duplexing. The data will be duplicated in the second disk. How it will
Mhm.
be? For example, this is what you assume that RAID 1, okay? Disk duplexing. So you have something like a disk, right? So this is like a disk. We have the disk. Disk 1, disk 2, disk 3, all those, right? We have the disk.
Mhm.
So this is like mirroring. We have one more disk, okay? Disk
Mhm.
array controller, DAC is nothing but disk array controller, will have that information like if this disk failure, okay? If the actual disk
Mhm.
failure, it will
Mhm.
tell like go and take it in the mirror disk. This is actually the
Okay.
mirror disk. Okay.
Mhm.
So mirror disk. The data will be stored in a mirror disk. You remember if you are going for mirroring it, you have to record for 1 terabyte of data, you need to have 2 terabyte of disk. Data is fully replicated on the mirror disk. Whatever the
Okay.
data is available here, it will be mirrored out. It will be mirror.
Okay.
Okay, we are not going to do any replication or we are not going to take backup. It will automatically DAC will take that whatever the data it's storing here, right? The same way
Okay.
parallelly it will store here also.
Mhm.
If you delete record here, it will automatically delete here also. But you have 100 terabyte of disk, then 200 terabyte of disk recorded. 100 terabyte of data you have. If you are going for RAID 1 concept, you need to have 200 terabyte of hard disk.
Yeah.
Got
Double
it?
it will be required.
Double the storage. Okay. So this is what I explained. Like RAID 1 is nothing but the mirroring. So D1, D2. The disk 1, you'll have disk 1 mirror. Disk 2 will be mirror. Disk 3, 3 will be mirror. So this will be disk 1, complete disk 1 and disk 0 and disk 1. Within the disk, you will have like a mirroring. Okay. So this will be a mirroring one. This is also.
Oh.
So either one disk controller will be there or two disk controller will be there. Duplexing. So it's more advantage. So two disk controller will be there to maintain the separate way. If one path will get failure, the other path will take it like data. This is for
Oh.
the RAID concept. Okay.
Oh.
RAID 5 is nothing but something like parity. Okay. Parity. So there it is maintaining like disk 1 and disk 1, disk 2, disk 3 is same like this way, right? But how it will be maintained here, RAID 5. Okay. Stripping with parity. So how it will be data divided into even number of blocks, okay, even number of blocks with additional parity block. So where it will have been. So for example, here I have A1, B1 and C1. For the A1, you will have the block in different way. Here you have the parity block. Okay, this will have all the A data, the parity data, wherever the A
Oh.
is present. Then C will have C1, C2, C3 will have here something different disk. You will have the C data. So D is not available here, right? So D1, D2, D3 for parity blocks it will be maintained here. Okay. So
Okay.
this is what you can reduce something like data storage. If any one of the drive has been failure, data recovered with remaining blocks, the parity informations. So this is what you can take it like RAID 5 concept. So they will go for RAID 1 normally.
Then all D1, D2, D3 data will be stored in parity
Yeah,
disk
parity
only.
disk, yes. Like mirror.
Oh.
Okay, so you have the disk one, mirror disk you will have always. This is like logical unit, one logical unit. LUN0 is nothing but one logical unit. One logical unit will have all the blocks and you will have a mirror block also. This is called RAID concept. Disk level failure, you have RAID. So disk
Okay.
level failure, you have RAID concept. Node level, we have hot standby. So amp level, you have fallback. Okay. What is that fallback? For example, you have 4 amp. Assume that you have 4 amp. Amp 0,
Okay.
amp 1, amp 2, amp 3. If 1 amp is failure, then the data has been stored in this amp is you cannot retrieve, right? We are not going to
Yes.
store the data in the amp, but the structure will be maintained here. It will access through this amp only. The data we are fetching through amp only.
Yes.
If 1 amp is failure, then it will be difficult to retrieve the data. For that, whenever you are creating a table, we will create a table with fallback. So in our environment, whenever we are creating a table, even though it is default, if you are not mentioning, it will be created as fallback table only.
Okay.
So by default, sometimes you can find like a table with normally it's a no fallback table, right? By default. But in real time, in our environment, we have fallback table. Fallback table. So what is that fallback table? The mirroring happened on the amp level. So amp level, the mirroring will happen. So for example, the record 62 is coming here, right? The same 62 will be maintained in some other amp also in the mirror, in the fallback rows. Okay, 62 is here. The 62 are on the fallback.
Oh.
If this has been failed, this amp has been failed. So 62, 8 and 27 will be on different amp. 62 will be on this amp, right? 8 will be on this
Yes.
amp. 27 will be on this amp. Got it?
Oh. Oh.
So yes, one amp has been failure. The data can be retrieved on all other amp. This is called a fallback. Whenever you are creating a table, you should mention that by default it will be no fallback. But if you want to create a fallback, again it's overhead to the storage. But the retrieval is very easy. So whenever you are
Oh.
having some critical data, right? Some
Yes.
sensitive informations, for that we will create like fallback. Next one is like node level. Node level we will collect like click. So I told you, right, the node will have something like node 1, node 2, node 3. It's a cluster, like horizontal way of storing the data, correct? So
Okay.
one SMP will have different node. So SMP 00001 to 009. SMP 001, something like 1 to 10, something like 11, 12. Okay. So you have something like different numbers you have. So
Yes.
SMP, this is one SMP. One SMP is having some node number 0, 1, 2, 3 up to 9 node we have. So all the node will be created by based on the sharing the disk. Okay. For example, if the node is disk controller, it is storing here. The same will be connected to the another disk also, disk A. This can be a mirroring option also. Okay. Disk A will be here also. Click. This is one click. Okay. If any one of the node has been failure. Okay. If one of the node has been failure, how the data will be. For example, this is node 1, okay, node 2, node 3, node 4, okay. Always you'll have one hot standby node. Whatever the activity which has been taken care by this node 1 will be transferred to hot standby node. So whatever the activity has been taken care by this node, right? So all the activity will be given to the node, the hot standby node. This will become node 1 now. After that, we will rectify this one and then we will make this as a hot standby node. Once you are bringing up this particular node, this will act as a hot standby. It will not act as a node 1 again. Okay. It will act as a hot standby node. If any of the node is failure, whatever that it will be processed, the database is processing, it will be transferred to this particular node, then it will become a hot standby node. So this is what it will be maintained, the click concept. In case of node failure, so it will be transferred to other node, whatever the handled by this disk and everything. So there won't be any failure. Okay. The locking system I will tell you after some time. So how the locking will be while we are creating the table, I will tell you that locking. Okay, locking alone I will tell you. Here we have seen that the disk level it's called read, amp level it is called fallback, the node level we will call it as click. Okay, technology. This is what the data protection in the Teradata. Got it? Sometimes in the interview they might be asking this concept.